Great, so let's check out example 4. Calculating the size to find area measures. Sometimes it seems as though not enough information is given, but look closely and think about what you might be able to calculate to help you find the area. So we have this composite shape. Very straightforward. We have a rectangle here, and we have a triangle here. Now there's a specific type of triangle that we have here. Now you may want to pause the video and try to figure out for yourselves. If not, then just follow along. So here, the area. So we have, let's label this as area 1. And let's shade it this way so that we know. And then we have area 2, which would be our triangle. Okay, I should have shaded it the other way, but fine. Good. So now, well, for the area of area 1, which is our rectangle, we need length times width. Length times width. Now, we know what the width is, but we don't know what the length is. And then for area 2, we have a triangle. And there's a specific type of triangle. This triangle, what does that tell you? That is 90 degrees. So this is called a right angle triangle. Let's write down the formula for the triangle. Base times height divided by 2. Okay, let's have these two formulas as a reference. One is for the rectangle, the other one is for the triangle. But we need, for the rectangle, we need to find the length. Now, can we find out the length? How do we find out the length? Well, we have this triangle here that can help us. Let me just redraw this triangle in a different way, and let's draw it here on the side. Actually, I want to be more consistent, so, well, a little more neat, I meant. So let's draw this triangle here like that. Alright, it's a sketch. This is 4 centimeters. This is 4 centimeters. If it's a right angle triangle and we need to find this side length, let me just draw it with a dotted line here. This side length, which is this one over here. I moved the camera accidentally. This one over here, right? This side length. If we need to find out this side length, let's call this side length, let's call it L. Or C, let's call it C. Why am I calling it C? Because it's the longest side, and the longest side is called the hypotenuse, and is opposite the 90-degree angle. So let's call this C. So we can use the Pythagorean theorem to find the length of C, which eventually is the length of the rectangle. So let's do that. So we know that the formula for the Pythagorean theorem is C squared equals to A squared plus B squared. Now, if this is 4 centimeters, this is also 4 centimeters. They tell us, the tick mark tells us that these two sides are the same. So C squared equals to 4 squared plus 4 squared. And sorry, I should have done this as well. If this is C, that means that this is A and this is B, but they happen to be the same length. So C squared is equal to 16 plus 16. C squared is equal to 32, and, well, we need to square root 32. What is the square root of 32? Well, you put it in your calculator. I'm going to round it off. I'm getting 5.7 centimeters. So now we know what the length of this is. With this information, we can find the rest of this. We can find the area of the rectangle. So let's start with that. So the area 1, which is the area of the rectangle, would be length, which is 5.7 times 3. Well, this is equal to 17.1 centimeters square, and the area of the triangle, which is area 2, would be base times height. Now, what is the base of this triangle? It's 4 centimeters, and the height is 4 centimeters. So 4 times 4, base times height, divided by 2. Well, that gives us what? 16 over 2. What is 16 divided by 2? Is equal to 8 centimeters square. And of course, the total area for this thing, for this shape, would be the addition of these two areas. Area 1 plus area 2, which is equal to 17.1 plus 8 centimeters. That gives us 25.2 0.1 centimeters square.